All good scientists are driven by a thirst to know what they don't know yet. For some, that goes past our usual horizon to the far reaches of space, to pulsars and black holes. Victoria Kaspi is just such a scientist, and she joins us now via Skype from Montreal, Quebec, where she is director of the McGill Space Institute and a professor of physics at McGill University. And Professor Kaspi, it's great to have you on TVO. How are we doing tonight?
I'm doing great. Thanks for having me.
Excellent. I want to start by asking you about some numbers that are truly mind-boggling and get you to help us understand this. Astronomers seem to be baffled by what seems to be the largest, most luminous exploding star ever discovered. Apparently, it is 200 times more powerful than the typical exploding star and 570 billion times brighter than our sun. What is baffling about this event exactly?
Oh, it's an amazing event. It was discovered by telescopes in Chile. And what's amazing is that we know it's some sort of supernova explosion. That is, we know it's the cataclysmic end of a star after it's lived out its lifetime. But the sheer numbers in terms of energy released are really confusing because we didn't think that was possible. We have some ideas for what could have been driving this explosion, what the energy source is, but we're not yet 100% sure. There's lots of ideas, lots of theories, but none of them worked perfectly. So it's an interesting mystery.
Well, can you help us out with some of those theories? I mean, why would a star explode?
Yeah. So that actually is pretty well understood. Stars explode. I know it doesn't seem like it, but we know they explode pretty often, at least by astronomical standards. So in our own galaxy, we know of typically roughly 2 of these explosions, these supernova explosions, happen every century. Generally speaking, they're pretty dim and you can't see them. They're obscured by dust in our galaxy. But we know stars explode, and the reason is because what a star represents, including our own sun, is a delicate balance between the inward crushing pull of gravity, because naturally matter would want to collapse on itself, and an outward thrust, outward push of hot, dense gas that has very high pressure. And so normally a star, like our sun, which is stable, represents a nice balance between those opposing forces. In a supernova explosion, what happens is that inside the fuel that powers that gas pressure runs out. Eventually, stars run out of fuel to keep them powered, and then gravity wins, the star implodes, and in that process, it releases a huge amount of energy. And that's what a supernova is. And we've witnessed supernova in our own galaxy. Kepler witnessed one in 1604, a really powerful explosion, would have been very impressive by today's standards. And our galaxy is actually due for one. Anytime in the next century, there is likely to be one. But this new source is even more luminous than any supernova, is far more luminous, I should say, than any supernova we've seen yet. And so that's a little baffling. We know that a collapse of a massive star can produce a supernova, but this one is so powerful, you need a really massive star. And we think those are both quite rare. And exactly how to release all that energy is one of the problems.
Now, our sun, of course, is just another star. Do you expect it to explode someday?
Yeah, so that's a really, really good question. And one thing that we understand really, really well in astronomy is stellar structure and how stars evolve. We know for a fact the sun will never have a supernova explosion because it's just not massive enough. It will eventually run out of the nuclear fuel, as all stars will, but the collapse will be a lot more gentle. And it's true, the atmosphere of the sun will eventually puff up and engulf probably the inner planets, certainly, but that's on several billion-year timescale, so I wouldn't worry about it too much. But there'll never be a huge explosion like we see in more massive stars.
Let me ask you about a different kind of star, which are neutron stars, your area of expertise, which you'll be talking about tomorrow night at the Perimeter Institute in Waterloo. What are neutron stars?
So neutron stars, they're really wonderful stars. They actually represent the endpoint of one of these supernova explosions, and I can't say for sure that it's the endpoint of this really, really massive explosion that you referred to earlier, but of a typical supernova, we think most of them will end up as neutron stars, and that is the dense collapsed remnant, something that has most of the mass of the interior of the former star, collapsed into a region the size of just a city, but containing almost 50% or sometimes twice as much mass of this as the sun. So a neutron star is an extremely dense object where if you could go up to it, and I don't recommend that anybody ever try such a thing, but if you could take a little teaspoonful of this matter, it would weigh 1 billion tons.
How is that possible?
So what happens in what we call a gravitational collapse, when the central portion of these massive stars collapses under its own gravitational forces, all of the empty space that usually exists in atoms, that is, a typical atom, like what we're made out of, what the table's made out of, what the air is made out of, those atoms actually have tons of space in them. There's a nucleus where you have protons and neutrons, and they're surrounded by these buzzing electrons. So a typical atom in all matter that we have on Earth has lots of empty space in it. Whereas in a neutron star, the gravitational collapse that forms it crushes that matter so that all that empty space goes away, and it's almost like just having a star made of nuclei of atoms. So it's not matter like we have here on Earth, or really could ever hope to create in a terrestrial laboratory.
Okay, that I get, but I also note that the title of your talk is The Cosmic Gift of Neutron Stars. Why are they a cosmic gift?
Yeah, they're wonderful objects to study, not just because they represent these sort of physical extremes, huge densities, and also, I should say, they're extremely magnetized, very high magnetic fields. For example, in some neutron stars, if you put a neutron star at the distance of the moon, it would wipe out all credit cards here on Earth totally clean because of that intense magnetic field. But in addition, they rotate really rapidly. And this is sort of, I say this and I continue, even though I've worked on neutron stars for, over 20 years, I say it still with amazement. Some of these objects rotate hundreds of times per second. That is as fast as, your kitchen blender. And when you have a star rotating that fast, what it represents, what we can use it for, is an amazing cosmic clock, because we go to telescopes and we can see that rotation because there's a bright spot on the surface of the star, which we see flash each time the star rotates. So by detecting those flashes, these objects are like little cosmic clocks. And we see these, like lighthouses in the sky, these little beacons can be used to study a whole wide variety of different types of astrophysics. So on the one hand, neutron stars are great for studying matter in extreme densities. But on the other hand, they can be used as probes of, for example, interstellar space, or as probes of different types of dynamics, how stars move. Because some of these pulsars, or these neutron stars, we find them around other stars and orbiting other stars. And we can use the clock-like properties to study that motion with exquisite precision.
All right, let me ask you about another mission that I have heard that you are on, and that is you would like to find a pulsar with a black hole. How come? What would that prove?
Oh, my goodness. That is one of those really, predicted theoretically. It's an object that should be out there. We should have neutron stars in orbit around a black hole. They should exist in our galaxy. They should be very rare. We know that. But if we could find one, we could use those amazing clock-like properties of the neutron star to study the dynamics around that black hole. And black holes, as are super extreme objects. They're totally collapsed beyond detectability even. So they're very hard to observe. But if you could find a neutron star around one of them, we can study the clock, like the pulsations, these light bursts from the neutron star, and measure the gravity around the black hole. And there's different theories of how gravity should work near black holes. Because it's such intense gravity, Einstein's theory of general relativity makes very clear predictions about how space-time should be, the geometry of space-time, how the neutron star should move. But it's really not been tested in regimes where that gravity is very strong. We know that Einstein's general relativity works where those forces are pretty weak, like in our solar system near the Earth. But in regimes like near black holes, Einstein's theory is not well tested, and we could use neutron stars to put it to a really ultimate test.
Let me follow up on that with this. Do you think there is any connection between neutron stars and extraterrestrials?
You know, I get asked that a lot, and the answer is there's absolutely no evidence for that. But the reason that people bring this up a lot is because when you have a cosmic source that is going beep, 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 as neutron stars do, the first thing you think of is some sort of intelligent life form. And in fact, it's interesting, when neutron stars were first discovered in 1967, the discoverers' first thought was that they were aliens, that they were alien beacons, until they started discovering them all over the sky, and it was very clear it was a natural phenomenon. And so I could understand why people would wonder about that, but there's absolutely no evidence whatsoever. We understand neutron stars, the physics, how they're born, how they live, how they die. It's very clearly a natural phenomenon that is part of stellar evolution, how stars die and the remnants they leave behind.
Do you think this universe of ours contains extraterrestrial life?
Yeah, so, you know, we have not found any evidence for that, but if you're asking my personal opinion, I think it seems very reasonable that there should be life somewhere else out there. The conditions to form life, we know, are not simple, not trivial, but there's so many stars in our galaxy and so many galaxies in the universe, it seems pretty unlikely that life would only form in this one location out of the billions of stars and the billions of galaxies in our universe. So if you ask me personally, I do think that it's likely, but what's less likely is that we will ever detect it, certainly in our lifetimes, mainly because space is so big and stars are so far apart. And if you actually think about the amount of time that humanity, people on Earth, have had the capability technologically to be able to communicate at interstellar distances, it's such a tiny fraction of the lifetime of our planet. You know, our planet's been around for 10 billion years, but you know, how long have we had radio communications? It's 100 years, maybe a little more. And so 100 years out of billions of years, that's a really small fraction of our lifetime. And presumably that fraction is going to be similar for other civilizations elsewhere. And so given the vast distances and the fraction of time, the amount of time it takes to develop this kind of technology, to get those two civilizations at the same time and within shooting, well, I shouldn't say that, but
I know what you mean.
Talking distance, it's really, the probability is really small.
I don't know if you pray, but if you do pray, can I assume that you are on your knees every night hoping against hope that you're going to find an extraterrestrial someday? I mean, that would be the absolute crowning achievement of any scientist's life, wouldn't it?
Absolutely. I mean, that would be really an amazing thing to do. And there are scientists out there who devote their lives to those kind of investigations. There's the Search for Extraterrestrial Intelligence, or SETI, where they try and design instruments trying to foresee how aliens would communicate. I have to say that I haven't spent a lot of time doing SETI kind of work. I tend to work on things that I think are less of a long shot. But on the other hand, I really respect people who do that, because it really is the first time in mankind's history that we've had the capability. So why not take a look?
Victoria, I suspect you and I literally have only one thing in common. You're a brilliant scientist and I'm just a guy on TV. But I think that we both loved Star Trek. What influence did Star Trek have on you?
Oh, wow. Yeah, I certainly do love Star Trek. I watched it as a child in reruns, and I found it really inspirational. The idea that certainly that humanity could one day not just travel among the stars, but travel in an optimistic, hopeful way, spreading messages of peace and trying not to interfere with other systems of life. I found that really inspirational. I enjoyed the characters. They're interesting characters too.
Are you capable of watching the show without your astrophysicist's hat on?
Yeah, so it is definitely true. There's some episodes where you watch it and you go, oh, come on, that's absolutely impossible. But on the other hand, yeah, so I can turn that off. I enjoy science fiction as much as the next person, and you're right, you have to turn off that part of your brain, but I could still enjoy it, sure. They're great. I mean, the characters are amazing, Spock, McCoy, Kirk, I love those people.
So you're clearly a classic as opposed to a Next Generation Star Trek fan. If I got that right?
Yeah. Well, okay, Picard, I love Picard too, I gotta say, and Data, yes, I love those people too, but my heart will always be with the classic episodes.
Gotcha. Here, when J.J. Abrams rebooted the Star Trek movie franchise back in 2009, you apparently did a review, and here's some of what you wrote. You said the original series was about exploration and boldly going where no one has gone before. This movie is about defending ourselves from a vicious, insane monster who appears out of nowhere. In the old series, what's out there, the unknown, is interesting and worth studying and examining. In the new movie, what's out there is frightening and potentially catastrophic. The difference in focus between the old series and the new movie, what does that say in your view?
Yeah, well, I feel that there has been a sort of transformation in society from, the early days, 1960s, 70s, where there was a wonder about space, an excitement about exploration. What can we achieve? What can we hope to achieve? A hope and a promise of science as something that would, really do amazing things. And actually, I think, objectively speaking, if we look at everything technology has brought us, overall, it's amazing. I mean, our life expectancy, thanks to modern medicine and our ability to communicate and the internet, has really transformed so much of our lives in such a positive way. And yet, I feel, at least as a scientist nowadays, that if anything, the tide has turned against science, that there's a mistrust of science and almost a resentment of people who've devoted their lives to scientific endeavors and to trying to understand nature and all its complexities. I don't understand why that should be. I feel science has really given so much to society, and yet, this mistrust in terms of, for example, the climate change denying, or people who don't believe that evolution is valid. Those are topics that are really based on the same sort of scientific principles that we've based modern medicine on, and what has allowed us to build wondrous things like cell phones and the very technology that's allowing me to talk to you right now. So we know those work. So why would we have such a vast mistrust of other scientific studies? I see that has been a transformation over the years.
That seems to be the age we live in, though. We are mistrustful. I shouldn't say we, because it's not everybody, but there are just so many people nowadays who are mistrustful of science, politics, the arts. I mean, pick your institution. It's everything, right? So I guess as a scientist, you shouldn't necessarily feel picked on because it's everywhere, isn't it?
Yeah, I see what you're saying. I see that is true. But there's also, another point that I think is worth making from a science point of view, especially when it comes to government policy. And here I'll just say, I think, south of the border, the issues are different than north than here in Canada, and I'm actually quite grateful for that. But for example, scientific research, some of scientific research, and in particular, admittedly, what I spend my life doing is really research that is fundamental in the sense that it doesn't have obvious applications that are going to bring societal benefits on a few-year time horizon. And increasingly, it seems like in our societies, we demand that of science. We want to know we want to fund science where, the applications and the benefit to society will be clear on, really quickly. Whereas so much of scientific progress and the benefits that have come to society take years to realize. So I like to give the analogy of, if a government in the late 19th century wanted to find a way to increase productivity by allowing people to, say, work after dark, they would pour government dollars into finding better ways to make candle wax or better wicks, because that's how we knew to do lighting. Whereas they didn't see the technological revolution of electricity that was going to be coming because it's something within their imagination. And that's where I think fundamental science really plays an important role. You have scientists who devote their lives to thinking about topics that seem quite esoteric in today's world, but could have huge benefits, on several decades timescales.
Victoria, that's our time. I want to thank you so much for joining us on TVO tonight, and I don't know if you can see me, but it seems appropriate to finish off this interview by saying, live long and prosper.
Thank you. Same to you.
Very good. And just a reminder, Professor Kaspi is one of the featured speakers at the Perimeter Institute's public lecture series. Tomorrow night at 7, she'll be giving a talk entitled The Cosmic Gift of Neutron Stars. We'll live stream it on our website, tvo.org, so please check out our website for more details.
Help TVO create a better world through the power of learning. Visit supporttvo.org and make a tax-deductible donation today.